6.2 has to do with the natural base e. So if you watch the video that I have linked from Numberphile, a very good video on what e is, and just remembering that it is natural base e is just an irrational number. It's very similar to pi. And so the irrational number e is approximately 2.71828182846, and it keeps on going, right? That's the definition of an irrational number. It doesn't repeat, and it goes on forever. Just remember that e is the base rate of growth shared by all continually growing processes. It shows up whenever systems grow exponentially and continuously, such as population, radioactive decay, interest calculations, and so much more. Even jagged systems that don't grow smoothly can be approximated by e. So e isn't an obscure random number. E represents the idea that all continually growing systems are scaled versions of a common rate. That comes directly from Better Explained, an intuitive guide to exponential functions and e by Khaled Azad. Now, more than anything, we're going to practice exponent rules here. And so just remembering, what do we do? So we're looking at e. It's a number, but the simplest way to write it is just by writing e. Just like pi, we write the symbol pi. Okay, so it's somewhat like a variable, but really it's a number. Okay, so just remembering that distinction. Now, we have the same base here, e to the third times e to the sixth. So remember, what do you do with that when it's the same base? Well, you add the exponent. So therefore, this becomes e to the 9th power. Then letter B, we reduce or simplify these numbers here. So 4 goes into 16 4 times. And then you subtract the exponents. So therefore, this becomes 4e to the 1st power, or just 4e. Letter C, you want to make sure and distribute that to every single term. Now, when it's power to a power, remember you multiply the exponents. So this is 3 squared e to the negative 4x times 2. So this becomes 3 times 2 is 9, and then e to the negative 8x. Now we should write it with positive exponents, so let's rewrite that. Remember that the negative only belongs to that e, so really this should be 9 over e to the 8x. Okay, the other one that I'm going to do is number 6. So number 6, we have 27 over 4, so that's not reducible, so we leave it alone. Then we deal with the e to the 7, e to the 4th. We're going to have more e's on the top, so subtract 4 from the 7. So therefore, this one is 27e to the 3rd over 4. So try the rest of these out. This was what was for homework, at least for Mrs. Wilkie's class. And so just to get some more practice with exponents, because we will be doing with exponent rules later on this chapter.